Hello students, welcome to my YouTube channel MS Maths. I hope all are fine. So in previous video I explained about the properties and some examples related to complex number. So today I am going to start exercise 2.2. So let us start. Number 1, determine the conjugate and the reciprocal or multiplicative inverse of each of the following complex numbers. So this property is already I explained in previous video. So today I am not going to explain again. I don't want to repeat the properties. So let us do the sums. If we do the sums, if we do have the practice, then we can understand everything. So number one minus I. Here we have to do conjugate and reciprocal. So conjugate, here I have written conjugate. What is the meaning of conjugate and what is the meaning of reciprocal? That is what I have written here already. So if a complex number, that is a plus ib, its conjugate will be a minus f. Just the sign of imaginary part will be changed. Secondly, reciprocal or multiplicative inverse. If a plus ib is a complex number, so 1 by a plus ib is the multiplicative inverse. So it is very simple. So anyhow, whatever complex number, always try to get it a plus ib form. If we don't have this form, this is called standard form of complex number, a plus ib, then to do any kind of properties, any kind of sums of complex numbers, it will be difficult for us. So better we have to get anything, any complex number in the form of a plus ib. So this one can be written as 0 plus I minus 1. This is a plus ib form. So a plus ib form, if it is, then it is easy to do any other properties or anything. So always try to get complex number in a plus ib form. So now what is to be done? Conjugate. So what is conjugate? So sign of imaginary part will be just changed. We have to change the sign of imaginary part. So its conjugate will be conjugate is what? It is in the a plus ib. So we will have a minus ib, that means 0 minus ib. 0 minus ib. Okay, its conjugate will be then 0 plus I, and on 0 plus I is I. So number 1 is finished. Conjugate of minus I, directly you can add plus I, but better we do this way so that you can understand. Because what is conjugate? Conjugate means we have to change the sign of imaginary part. So sign of imaginary part here minus, so we can write directly plus I, means only I. So it's very simple. I is given, that means plus I1. I means what? Plus I dot 1 plus IB. So answer we can write directly minus I. Anyway, now here we have to do also reciprocal. Reciprocal means multiplicative inverse. If z, then 1 by z or z inverse. What is z? Minus I. Reciprocal will be 1 by minus I. So 1 by minus I. What we have to do here? Here I is in denominator. So always try to remove I from denominator. So what we will do? We will multiply by I or minus I, no problem. 1 into minus I. So minus into minus is plus. I into I is I square. Again minus 1. Or what to do? You do one thing. It is better. Minus I into I 1 into I. I into I is I square. I square is minus 1. Minus into minus plus. So I. So I. So reciprocal of minus I is I. So here reciprocal of plus I will be reciprocal of number 2. I will be 1 by I. 1 by I, what we will have to do? Just we will multiply by I in numerator and denominator, so that I by this one I into I square minus 1, so directly minus I. So this minus I is reciprocal of I, number B. Now number C. Number C. First, this is Z, means A plus IB. We have to write conjugate. We have to write its conjugate. So it will be, its conjugate will be 2 minus I. There is nothing to think. Just A plus IB will be A minus I. Now we have to find out its reciprocal. Reciprocal will be what, 2 plus I, so 1 by 2 plus I. If 1 by 2 plus I, as we know, same process, in denominator always we have to multiply by same but opposite side, means A plus IB, A minus IB, this already I explained it. So since multiplying by 2 minus I in denominator, so you must multiply numerator also. This one A plus B into A minus B, what is the formula? A square plus B square. A square plus B square. B is 1 here. A plus IB. A minus IB. B is 1. So here 2 minus I is left. So shortcut, no need to do again and again, step by 2. 2 square is 4. 4 plus 1 is 5. 2 minus I. So this one can be written 2 by 5 minus I 1 by 5. A minus IB form or A plus IB form. First A, then B. So before B, I is supposed to be written. So I have written like this. So this is very simple. 1 by 3 plus I. Number D. 1 plus 3, 1 by 3 plus I. First of all, this one you have to make it A plus IB form. Then only we can go for conjugate or reciprocal, whatever it is. But this is not in A plus IB form. Let us try to get in A plus IB form. So as I have told you here, same thing here also we have to do. 3 plus I, we will multiply by 3 minus I. Then it will be 3 square plus 1 square. A plus IB into A minus IB, I1, so 1 square. 3 minus I, 3 square 9, 9 plus 1, 10, 3 minus I. So this will be 3 by 10 minus I 1 by 10. This is A plus IB form. Its conjugate will be, just we have to change the sign of imaginary part. Conjugate will be 3 by 10 plus I 1 by 10. Conjugate. This is conjugate. Now we have to find out the multiplicative inverse. Multiplicative inverse will be directly, let me write, 1 by 3 plus I will be 3 plus I by 1. So 3 plus I by 1, directly we can write 3 plus I only. There is nothing to do. 3 plus I. A plus IB form. I hope you understand this one. 1 plus Z equals to 1 plus 3, 1 by 3 plus I. So Z inverse will be 1 by 3 plus I. So this will be converted. This will be reciprocal. 1 by 3 plus I will become 3 plus I by 1. So 3 plus I by 1 I have written. So this is finished here. Now number E. Number E, let me rub this one. Let me erase this one. You can pause the video, you can write it if it is difficult. It is very easy, so you don't have to write also. Let me do number E here. Number E. A plus IB. Its conjugate will be directly A minus IB. Change the sign of imaginary part. Now its reciprocal will be 1 by A plus IB. But this is not the answer because this is not in the form of A plus IB. So what we will do, we will multiply by numerator and denominator with A minus IB so that imaginary part will be removed from denominator. A square plus B square. A plus, this is formula, A minus IB. So we can write A by A square plus B square minus I B by A square plus B square. I hope you understand this one. This is not so hard. So exercise 2.2 number 1 is finished. I hope you understand this one. If any problem, please have writing some in a comment box so that I can explain again if there is any issues. Number 2. Express in A plus IB form. So as already I have told you that complex number, if we don't get in A plus IB form, then it is difficult to do all kind of sums in complex number. So anyway, here it is very simple. A plus B whole cube formula we can apply here. A cube plus B cube plus 3A square B plus 3A B square. Just A plus B whole cube formula is applied. 1 cube is 1, I cube is minus I. Already I explained here. I square is 3 into I, 3I. This is I square is minus 1, minus 3. 1 plus 2I. Minus 1I plus 3I is 2I, minus 3. This one you can write directly. 1 minus 3 is minus 2 plus 2I. Now this is not finished because we have to convert into A plus IB form. So here what we will do, we will multiply by minus 2 plus 2I with minus 2 minus 2I. Here also minus 2 minus 2I. Now we will go here. Here minus 2 minus 2I. Here A square plus B square. A square plus B square. A is minus 2, B is 2. So 2 square is 4, 4, 8. Minus 2 minus 2I. Here one thing we can do, 2 can be taken common because 8 is there, we can cancel. We can make it small. Minus 1 minus I. 8, 2, 4. Minus 1 minus I by 4. Minus 1 by 4. Minus I 1 by 4. This is A plus IB form. A plus IB form. A, B. First real part, secondly imaginary part. Number 2. This one what we will do, same process. We are trying to remove I from denominator. So that is why multiply by I minus 1 in numerator with denominator and numerator. So 1 square plus 1 square. This is I minus 1 whole square. This is 2 only. So I minus whole square, A minus B whole square formula, A square plus B square minus 2AB. 2 minus 1 plus 1 minus 2I. Cancel, minus 2I by 2. Cancel, minus I is left. So this is not the answer. Expressed in A plus IB. So 0 minus I dot 1. This is A, this is B. This is the answer. Number 4. Number 4, A plus AB whole square. A plus B whole square. A square plus 2AB plus B square. Bracket. Before bracket minus sign is there, so I am not going to remove the bracket. We will do the formula A plus B whole square. A square plus 2AB plus B square. 1 plus 2I minus 1. I square is minus 1. Okay, 4 plus 4I minus 1. 1 minus 1 here cancel. 2I minus, okay, write this one like this. 2I minus 3 minus 4I minus 3 minus 2I. Minus 3 is here. 2I minus 4I is minus 2I. This is number 4. So A plus IB form. Now number 5. Number 5. Just we will multiply. Let us see what we get. 3 into 12 is 36. 3 into 5I 15I. 4 12 is 48. I plus into minus is minus. 4 into 5 is 20. I into I square. 36 minus 15 plus 48. So we will subtract. 8 minus 5 3. 4 minus 1 3. Plus. Because before greater number there is plus sign. So plus 20. I square is minus 1 minus plus. 36 plus 20. 56 plus 33. A plus IB form. Number 6. 5 minus 3I by 6 plus. Same thing. Process is always same. Here 6 plus I is there in denominator. So we will multiply 6 by 6 minus I with numerator and denominator. So that is same. Always you have to apply this process. Whenever you get a complex number in denominator, so whatever it is, if it is A plus IB, multiply by A minus IB in numerator and denominator. Whenever you get complex number in denominator. So A plus IB, A minus B, A square plus B square. A plus IB into A minus IB is A square plus B square. A is 6, B is 1. So 5 into 6, 30. 5 into I, 5I. 3 into 6, 18I. minus into minus plus 3i square. 30 minus 23i minus 3. So 6 square is 36 plus 1, 37. 30 minus 3, 27 minus 23i by 37. If you keep the answer this way, then it will not be correct, because question is there given express in a plus ib form. So first there should be a, then separately b, ib. So 27 by 37 minus I 23 by 37. I hope you have understood. Number 7. Number 7 is little longer, so I have kept the last page of this video, so that you can do the sum properly. Now there are two fractions inside this bracket. Here also there is complex number in denominator. So let us do this fraction by taking LCM. One into 1 plus I, 2 into 1 minus 4i. I hope this one you understood. Here also 5 plus I into 5 minus I, 3 minus 4i into 5 minus I. This one taken LCM. 1 into 1 is 1 plus I, just multiplying, so you can check yourself. 2 plus 8i, minus 2 into minus 4i is 8i. This one 5 square plus 1 square. 3 into 5, 15. 3 into I, 3i. 20i plus 4i square. Now 1 plus I minus 4i is minus 3i. This is plus 4. I square is minus 1, minus plus. 1 minus 1. 1 minus 2 is minus 1. Plus I plus 8i plus 9i. So this one you have got from this. Here also let us see what do we get. 25 plus 1, 26. 15 minus 3i minus 20i minus 23i minus 4. I square is minus 1, so minus 4. Okay. Then 1 plus 4, 5 minus 3i. Here minus 1 plus 9i. Here we have got 26 down denominator. 15 plus minus 4 is 11 minus 23i. Still the sum is not finished, because here still I is left in denominator. That means complex number is in denominator. So this one also we will multiply by 5 plus 3i in numerator and denominator. Then we will get a simple form. Minus 1 plus 9i. So here one more is there, 11 minus 23i by 26. So 5 square plus 3 square. A plus ib into a minus ib is a square plus b square. Why I am repeating? So that it goes to your brain. It will be permanent in your brain. So every time you please repeat a plus ib into a minus ib, or a minus ib into a plus ib will be a square plus b square. So that's a formula. So if you repeat, if you go on repeating the formula, then you don't have to learn by heart again separately. So whenever you do the sums, please pronounce, please play yourself. So that it goes to your brain. Anyway, minus 1 into 5 is minus 5, minus 3i, 45i, 27i square. 11 minus 23i by 26. Okay. 25 plus 9 minus 5, 42i minus 3i plus 45. 45 minus 3 is 42. This is minus 27. 27i square is minus 27. That you know. This is 34. Minus 5 minus 27 minus 32 plus 42i. 11 minus 23i by 26. Here we will take 2 common. Why we are going to take 2 common? Because 34 is divisible by 2, so that we can make it small. Reduce to smaller term. So minus 16 plus 21i, 34. Here we could have, if we here suppose 33. In place of 34, if there is 33, there is no use of taking 2 common. So you understand, I think. 2, 17, the 34, 11 minus 23i by 26. So minus 16 plus 21i, minus 16 plus 21i by 17 into 11 minus 23i by 26. Still the sum is not finished. Little calculation is big, so you have to do very carefully. Now we will multiply. We will multiply. Minus 16 into 11, minus 16 into minus 23i, like this, as usual multiplication. So I am going to do directly because there is no space. Okay. Minus 16 into 11 is minus 176. Minus 176. Then minus 16 into minus 23 is plus 368i. Then 21i into 11, 231i, minus plus 21 into minus 23, plus into minus is minus. Then I square is there because both I. Then that is 483. Denominator 17 into 26 is 442. 442. So minus 176 plus 368i plus 231i, it will be 599i. 599i. I have done the calculation already. So by looking it, I have written here because otherwise it will take so much time. And then this is plus 483. I think you understand. Minus 483 I square is plus 483. 442. 442 minus 176 plus 483, we will subtract it. By subtracting, we have got 307 plus 599i. So this is the answer to number 7. It is written express a plus ib form. A plus ib form. So one more time, we will write 307 by 442 plus I 599 by 442. So this is a plus ib form. I hope you understand. Here only you have to be very careful while doing the calculation. Once you get small mistake, silly mistake in calculation, then you will not get the correct answer. So while doing this type of sum, this sum looks bigger, but the sum is easy. Depends upon your calculation. The process of doing calculation must be easy to you. That calculation must be done by you very easily. So number 2, I hope already finished. Number 3 now. Number 3, okay. Number 3, Z1 is given, Z2 is given. You have to find out Z1 by Z2 and Z1 bar by Z2 bar. So it is very simple. First, you have to find out Z1 by Z2. Already I have written here. So since complex number is denominator, so same process. Process is same. Only you have to do the calculation properly. That is the main part. So what we will do? 1 minus I we will multiply by 1 plus I. Here 1 plus I, again 1 plus I. So 1 square plus 1 square, a plus ib into a minus ib, a square plus b square. This is a plus b, a plus b, a plus b whole square. Let us write once. Then next step we will apply the formula a square plus 2ab plus b square to 1 plus 2i minus 1. I square is minus 1 plus 1 cancel. 2i by 2, that is I. So Z1 by Z2 we have got I. Now we will go to Z1 bar by Z2 bar. So I have written already Z1 is 1 plus I, Z2 is 1 minus I. Bar I have put as it is. Z1 I have written, bar is there, so I have put bar. Now 1 plus I bar. So it will be 1 minus conjugate. I have written here, if Z equals to a plus ib, then Z bar equals to a minus ib. If Z bar is a minus ib, Z will be a plus ib. So opposite to each other. So if it is 1 plus I bar, then 1 minus I. So this one again same thing. We will multiply by 1 minus I in numerator and denominator. Process is same. So this one 1 square plus 1 square, a plus ib, a minus ib. A is 1, b also 1. This is 1 minus I whole square. That means a minus b whole square formula. A square minus 2ab plus b square. A minus b whole square. So what I have done, please follow this way only. I have been writing the numbers, but while trailing, I have not told the numbers. I have mentioned the formula. So that way you also do that. Then there will be no mistake. 1, 2i minus 1. So minus 2i by 2. 2 cancel and answer is minus 1. So number 1 is finished. Number B. Number B. 3ab. Let me do here number B. B. Z1 equals to 7 plus 3i and Z2 equals to 3i minus 7. 3i minus 7. Let me write minus 7 plus 3i. Same thing. A plus ib form. Just I have followed a plus ib form. I is here. So I just have put this way so that the sum can be done very easily. So Z1 by into Z2. First of all we have to find out. So let us find out Z1 into Z2. Z1 into Z2. So 7 plus 3i into minus 7 plus 3i. So just multiplication only. 7 into minus 7 is minus 49. 7 into 3i, 21i, minus 21i, plus 9i square. Minus 49 plus 21 minus 20 cancel, and minus plus 9i square is minus 9, that is minus 58. Minus 58. Minus 58, yes. Then what we have to find out? Z1 bar into Z2 bar. Z1 bar into Z2 bar. 7 plus 3i bar into minus 7 plus 3i bar. So we will remove the bar now. If we remove the bar, imaginary part sign will be changed. This much only. Minus 7 plus 3i minus 3i plus 3i minus 3. Now we will multiply. 7 into minus 7 is 49. Minus 21i plus 21i minus into minus plus 3 into 3 9 I square minus 49 plus 21 minus 21 cancel 9. This is minus 58. Z1 bar Z2 is also minus 58. Now we have to find out Z1 by Z2. Z1 by Z2. Z1 is 7 plus 3i. This is minus 7 plus 3i. So here also minus 7 plus 3i we will multiply by minus 7 minus 3i. 7 plus 3i into minus 7 minus 3i. Minus 7 a square plus b square. A minus ib, a plus ib. A is minus 7, b is 3. 7 into 7, 49. 21i minus 21i minus 9i square. 49 plus 9 minus 49 minus 42i plus 9 minus 40 minus 42i 58. Okay, now we will take 2 common. Why? Because 58 is divisible by 2. Minus 20 minus 21i. So 229. What we have got? Minus 20 minus 21i by 29. Now we will add minus 20 by 29. I 21 by 29. Now we have to find out Z1 bar by Z2 bar. Z1 bar by Z2 bar. Z1 bar by Z2 bar. Z1 is 7 plus 3i. 7 plus 3i and Z2 is minus 7 minus plus 3i. So 7 minus 3i. Here minus 7 minus 3i. Bar is there, sign will be changed. Conjugate. So minus 7 minus 3i into minus 7 plus 3i. A plus b into a minus ib. Minus 7 plus 3i. A square plus b square. A plus ib into a minus ib is a square plus b square. Now minus 49 21i plus 21i minus 9i square. Equals to 49 plus 9. 7 square is 49, 3 square is 9. Minus 49 plus 42i plus 9. Minus 40 plus 42i 58. 58. So now we will take 2 common because 58 is divisible by 2. Minus 20 plus 21i by 29 minus 20 by 29 plus I 21 by 29. This is the answer for Z1 bar by Z2 bar. Then Z1 into Z2 bar. Z1 into Z2 bar. Z1 is 7 plus 3i. Z2 is minus 7 plus 3i. So 7 plus 3i into minus 7 minus 3i. 7 into minus 7 is minus 49, minus 21i, minus 21i, minus 9i square, minus 49, minus 42i plus 9, minus 50, 42i. Sorry, minus 40. It should be minus 40. Minus 49 plus 9 is minus 40. Minus 40 minus 42i is the answer. So this number 3 is number B is finished. We will go to number 4 now. Number 4. Z1 is given 2 plus 3i. Z2 is given 1 minus 2i. So we have to find out we have to verify. Number 1, left hand side Z1 plus Z2 equals to right hand side Z1 bar plus Z2 bar. Bar is there. So I have written already here Z1 plus Z2 bar. So Z1 I have put as it is. Z2 also I have put as it is. Bar is there. So 2 plus 1, 3. 3i minus 2i is I. Still bar is there. So now we will remove the bar. So 3 minus I. So this is finished. Now right hand side. This is left hand side. Right hand side we will do Z1 bar plus Z2 bar. Z1 is 2 plus 3i. Z2 is 1 minus 2i. So you will write here 2 minus 3i plus, here you will write 1 plus 2i because we have removed bar. 2 plus 1, 3 minus 3i plus 2i is minus I. So 3 minus I, left hand side, right hand side also 3 minus I. Number 2. Left hand side Z1 minus Z2 bar is there. Okay. Now what is Z1? 2 plus 3i. Minus Z2, 1 minus 2i. 1 minus 2i. Here I have put bracket because before bracket minus sign is there. If there is plus sign, then we will not put the bracket because minus sign change the things. So there is bar already. Remember that. Don't forget to put the bar. So bar is there. 2 plus 3i minus 1 plus 2i. I hope you understand. Bar 2 minus 1 is 1. 3i plus 2i is 5i. So we want to remove the bar. That means conjugate 1 minus 5i. So number 2 finished. Number 3. Number 3, left hand side Z1, Z2 bar there is. So I have put as it is the value. So after that we will do the calculation. Bar will be there. 2 into 1 is 2. 2 into 2 is 4i plus 3i plus minus minus 6i square. Again bar is there. 2 minus I, because minus 4i plus 3i is minus I plus 6. 8 minus I. 8 plus I is the value of left hand side. Now we'll go to right hand side. Z1 bar dot Z2 bar. Z1 is 2 plus 3I. Z2 is 1 minus 2I. So 2 minus 3I into 1 plus 2I. 2 into 1 is 2 plus 4I minus 3I minus 6I square. 2 plus I plus 6. 8 plus I. Left hand side and 8 plus I, right hand side 8 plus I. So verify. Number 4. Number 4. Okay. Z1 by Z2 bar. Left hand side there is Z1 by Z2. Z1 by Z2 bar. Bar is only single. Yes, bar is for single. So we will put as it is. We don't have any problem here. Z1 is 2 plus 3I and Z2 is 1 minus 2I. Now we will go on doing as it is. Whatever we have done in previous sum, here also we will do. While doing the sum, we don't forget to put this bar. So as 1 minus 2I is in denominator, so we will multiply it by 1 plus 2I, 2 plus 3I, 1 plus 2I, numerator denominator multiplied by 1 plus 2I. A plus B, A plus IB, A minus IB, A square plus B square. Here bar is there already. 2 into 1 is 2 plus 4I plus 3I plus 6I square. 1 square is 1, 2 square is 4, 4 plus 1, 5. 2 plus 7I, this is minus 6. 2 minus 6 is minus 4. Their bar is there already. Minus 4 plus 7I by 5. Bar is still there. Minus 4 by 5 plus I 7 by 5. Bar is still there. Now only we will remove bar. Because we have got A plus IB form. Then it is easy to remove bar. That means it is easy to convert into conjugate. Conjugate of A plus IB will be A minus IB. Minus 4 by 5 minus I 7 by 5. So this is the answer for left hand side. Now we will go to right hand side. Right hand side there is Z1 bar by Z2 bar. Right hand side. Let us do from here. Right hand side Z1 bar by Z2 bar. So we will write Z1. How much? Z1 2 plus 3I bar. Z2 1 minus 2I bar. So we will remove bar. 2 minus 3I. Here 1 plus 2I. Now we will multiply by 1 minus 2I. Numerator and denominator. 1 plus 2I. We will multiply by 1 minus 2I. 2 minus 3I. 1 minus 2I. A plus IB into A minus IB form. So A square plus B square. A square plus B square. 2 into 1 is 2 minus 4I minus 3i plus 6i square. 1 square, 2 square, 5. 2 minus 7i minus 6 minus 4 minus 7i by 5 minus 4 by 5 minus I 7 by 5. Minus 4 by 5 minus I 7 by 5. Right hand side, left hand side equal. So it is verified. Left hand side is equal to right hand side. Now number 5. Yes. If Z1 equals to 2 plus I, Z2 equals to 1 minus 3I, then find Z1 into Z2 bar and Z1 bar into Z2. Verify that these are conjugate to each other. So we will later on see that whatever the verification, first we will find out Z1 into Z2 bar. Z1 into Z2 bar, just I have put the value of Z1 and Z2. So Z1 is 2 plus I, Z2 is 1 minus 3I. Bar is there in Z2, so I have put bar. So 2 plus I into 1 plus 3i, because bar is there, conjugate. Now we will multiply 2 into 1, 2, 6i plus I plus 3i square. 2 plus 7i minus 3, I square is minus 1 plus 3. So minus 1 plus 7i. This is Z1 into Z2 bar. Now we will find out Z1 bar into Z2. So I have put the value. So this we will write 2 minus I. 2 plus I bar, 2 minus I into 1 minus 3i. Just we will multiply now. 2 into 1, 2, 6i minus I plus 3i square. So 2 minus 7i minus 3 minus 1 minus 7i. Here we have got minus 1 plus 7i. Here we have got minus 1 minus 7i. Verify that these are conjugate to each other. Yes, these are conjugate to each other. It's not it. Here in in imaginary part plus, here in imaginary part minus. So sign is opposite, so conjugate to each other. Minus 1 plus 7i is conjugate of this. Minus 1 minus 7i is conjugate of this. So conjugate to each other. Yes, these are conjugate to each other. So I hope there is no problem, no issues. Number B, if any two complex numbers Z1 and Z2, examine whether Z1 Z2 bar and Z1 bar Z2 are conjugate to same thing, but here complex number is not given. So we have taken Z1 is A plus IB, Z2 is C plus IB. Now first part is Z1 into Z2 bar. So Z1 into Z2 bar, so A plus IB, C plus IB bar. So we will do now A plus IB into C minus IB as bar is removed. Now we will multiply A into C, A into IB minus IAB. IB into C plus IBC, plus into minus is minus, I into I is I square, B into D, BD. This calculation is like algebra calculation. Though you don't have to worry that this is a complex number multiplication. Multiplication is same. So AC minus IAD plus IBC. This is plus BD, as you understand. I into I is I square. So minus I square is plus. I square is minus 1 minus minus plus. So let us write the real part together. AC and BD. There is no I. So written together. IBC, IAD. Positive part I have written first. You can write negative also, no problem. I is taken common so that it is clear to us that this is A, this is B. A plus IB form. I have written the answer means the value of Z1 into Z2 bar in A plus IB form. So this is what you have to do always. Now let us see Z1 bar into Z2. What do we get? So A plus IB bar was A minus IB. So we will multiply now. A into CAC plus IAD. IBC minus I square BD. So AC plus IAD IBC plus BD. AC plus BD real part together. AC BD real part I have put together. IBC plus IAD. I have written IBC first, this one second, because here also BC I have written first, so that you can make it same way, you can make it, you can compare it easily. So AC plus BD. Now I will take common BC minus AD. I has taken common, before I there was minus sign, so sign will get changed as you know it. AC plus BD, AC plus BD. BC minus AD, BC minus AD. Where what is the change? Here plus I, there is minus I. For any two complex number Z1 and Z2, examine whether Z1 and Z2 bar and are conjugate to each other. Yes. Here also, yes, they are conjugate to each other. Number 6. Number 6. If 2x equals to minus 1 plus I root 3, so 2i given, so that x square equals to y. So 2x equals to this is given. So I have done here x equals to this. 2 came there. So 2 will be going there in denominator. Here also 2y and y, 2 has gone this side. So that you know, that is just like algebra. There is nothing related to complex number. Why I have done like this? Because here everywhere I have seen x is there, no 2x, no 2y. Number 1 x, y alone. Here also number 2 x alone, x is alone. So we don't need 2. So 2 has transferred to this right hand side. So that is why I have done this way. You have to know the reason. Simply you cannot do the sum. Anyway, number 1, we have to show that number 1 x square equals to y. So left hand side, that means what? X square. X square. X is minus 1 plus I root 3 by 2 square. X square. X is this much. So this is 4. This one a plus b whole square formula. A square plus 2ab plus b square. This way, always write this way so that there will be no mistake. You don't do shortcut. If you do shortcut, then there will be some mistake. So as it is 2ab very nicely, write in proper way, then there will be no mistake, no chance of mistake. Minus 1 whole square is 1 minus I 2 root 3. Minus into plus is minus, I is there, so I written 2 root 3. 2 into 1 is 2. So I square is minus 1. So minus root 3 square is 3. So 4. 1 minus 3 is minus 2 minus I 2 root 3. Here of course we will take 2 common. 2 common because 4 is divisible by. So 1 minus I root 3 by 4, 2. So we have got minus 1 minus I root 3 by 2. Equals to y, directly we can write, because what is y? Y I have already found. Minus 1 minus I root 3 by 2. Minus 1 minus I root 3 by 2. X square is equal to y. Therefore, x square equals to y. Finish this one. This is y. Next, there is given number 2, xy equals to a plus aib. We have to show xy equals to a plus ib. So let us do left hand side first. Left hand side, xy. So I have written x and y. So we will multiply minus 1 plus I root 3 minus 1 minus I root 3. A plus ib, a minus ib form. There is plus and minus. A is minus 1. B is root 3. A square plus B square. What is A? Minus 1. What is B? Root 3. So A square plus B square. A plus IB into A minus IB. I repeat, A plus IB into A minus IB, which will be A square plus B square. So that is what, it is very easy. If you do multiplication, then only you will get this one. If you do simple multiplication, then also you will get this one only, but it will take time. So better you apply the formula. So 4, 1 plus 3, minus 1 whole square is 1, root 3 square is 3. So 4 by 4 equals to 1. Now, right hand side, a plus ib. So this one we can write 1 plus 0 dot I. Because imaginary part is not there, so it is same thing. Now this one, if you do calculation, some same thing you will get. This is a plus ib form. A is 1, b is how much? 0. So therefore a is equal to 1, b is equal to 0. I hope you understand. This one is written in a plus ib form. A plus ib form, where a equals to 1, b equals to 0. Yes, a equals to 1, b equals to 0. This is what we have shown. X number 3. What to show? To show that x is the multiplicative inverse of y and vice versa. X is the multiplicative inverse of y and y is also multiplicative inverse of x. So we know x already. I have written this side. X is this much, y is this much. We have to show x is equals to y inverse and y is equal to x inverse. So let us see y inverse. How much y inverse? Let us see. Y inverse, that means 1 by y. That you know already. Multiplicative inverse of z means z inverse. If z is a plus ib, z inverse will be 1 by a plus ib. That you know already. Already I explained. So 1 by y, y is, this one is y. This is a fraction. So this can be reciprocal. 2 will go up. So 2 by minus 1 minus 3. So this is complex number in denominator. So same process. Minus 1 y root 3 into minus 1 plus I root 3. 2 into minus 1 plus I root 3. Just multiplication as it is. In your copy, please don't put this type of arrow mark. This is for, because there is no space in this board. So I cannot go down. So I have put this way. You please don't put this way. This is not actual way. Okay, this is a square plus b square. Now we will multiply this. Minus 2 plus I 2 root 3. 1 plus 3. Root 3 square is 3. Minus 2 plus I 2 root 3. 6 number 3. Okay. This is 4 minus 2 plus I 2 root 3. Now we will take 2 common. Why? Because 4 is divisible by 2. So 2 minus 1 plus I root 3 by 4. 2 minus 1 plus I root 3 by 2. Y inverse is this much, equals to x. What is x? Minus 1 plus I root 3 by 2. Minus 1 plus I root 3 by 2. So y inverse is x. y inverse is x. Y inverse is x we have done. Just now we have done y inverse is equal to x. So multiplicative inverse of y is x. That is what we have just now proved. The same way you can do yourself. X minus x inverse equals to 1 by x. What is x? Minus 1 plus I root 3 by 2. So this can be written 2 by minus 1 plus I root 3. After that process is same. From denominator you have to try to remove complex number. Number 7. Number 7. Solve the following equation. This is an equation. We have to find out. Solve the equation means we have to find out the value of x and y. Value of x and y. So whatever process we apply, we have to get. We have done already in other lower general maths about linear equation in two variables, 3x plus 4y equals to 1, 5x plus 7y equals to minus 2. So that type of linear equations already we have solved. So that is what we have to do here also. But here the difference is that here there is I, complex number. So number 1, I have written here 3x plus 5i minus 4y. Sorry, this one no need to write again. 3x minus 4y. What I have done? Real part I have written together. Plus 5i equals to 10x minus 3y I. So this is real part, real part. This is imaginary part, imaginary part. So comparing, this one already I explained. Comparing real and imaginary part. Imaginary part, we get. What do we get? 3x minus 4y equals to 10. Instead of writing comparing, we can write equating. It is better to write equating, equate. Because we are doing equation, so you better write equating. Equating real and imaginary part. Real part equals to real part, imaginary part equals to imaginary part. So this is equation number 1. Then x minus 3y equals to 5. This is equation number 2. This one I have written this side, same thing, 5 equals to x minus 3y. X minus 3y equals to 5, same thing. So I have written this way so that it will be easy to do the calculation. So here single x is there. So we will do this way, 5 plus 3y. X equals to minus 3y goes that's 5 plus 3y. That value of x, 5 plus 3y, we will put here in equation number 1. 3 into x, 5 plus. Now whatever I am doing, this is not related to complex number. This is related to linear equation in two variables which you got already. Three into 5, 15. 9y minus 4y equals to 10. 9y minus 4y is 5y. Then minus 15 is minus 5. So y equals to minus 1. Y equals to minus 1. Now this one number 2. Now 2 implies x equals to 5 plus 3y. Y is minus 1. So 3 into minus 1. X equals to 5 minus 3 equals to 2. So answer x equals to 2, y equals to minus 1. So this is very simple. Just to equate real and imaginary part. Rest of the part, the remaining part is as like linear equation of two variables which you have already done in lower classes or in general maths. Number 2, same process. x plus iy plus 3 minus 2i equals to 1 plus 4i. Now we will keep real part together. X plus 3 real part plus I y minus 2 imaginary part. This must only real part, imaginary part, real part, imaginary part. So equating this, you will write yourself like this one. X plus 3 equals to 1. Real part, real part. Y minus 2 equals to 4. Here directly you can do y equals to 4 plus 2 equals to 6. We have got the value of y. Y equals to 6. So now here x equals to 1 minus 3 equals to minus 2. This is finished. It is very simple sum. X equals to minus 2, y equals to 6. X equals to minus 2, y equals to 6. This is very simple. This one also same thing. First we will try to find out real and imaginary parts separately. 1 into x, x, I x, 1 into y, y minus I y, 1 minus 3 I. Now we will keep real parts together. I hope you understand. I hope all of you have understood, because there is nothing new. So real part, imaginary part, imaginary part. Here what I have done, I is taken common. From these two, I have taken common, x minus y. So here what we will write, equating real and imaginary part, we get x plus y equals to 1, x minus y equals to minus 3. Please don't do this mistake. X minus y equals to minus 3. Here minus sign, here also minus sign. Then you could have written x minus y equals to 3. Because here a plus, here there is minus. Remember that. Now, as any process you can apply, directly you can add both the equation, directly you can subtract both the equation. Let me subtract both the equation. X, this is equation number 1, this is equation number 2. X plus y equals to 1, x minus y equals to minus 3. Equation number 1 minus 2. Equation number 1 and 2 you will subtract. That you know, I think. Let me show you again. X minus x cancel, plus y, 2y. 1 plus 3 is 4. Y equals to 2. Y equals to 2. Now, 1 implies 1 is x plus y equals to 1. X plus y. What is y? Y is 2. Equals to 1. So x equals to 1 minus 2. So x equals to, we have got minus 1. So answer is x equals to minus 1, y equals to 2. X equal to minus 1, y equals to 2. Number 4. Number 4. Number 4. Okay, number 4 we will do here only. Number 5 we will do next page, because there may not be enough space for that. Number 4 we will do now. Number 4, there is nothing new, but you have to do the calculation very carefully. Otherwise, because there is chance to have some mistakes because the sum is looking bigger. Now, what you will do, you will take the LCM of both denominators. LCM will be surely 3 plus I into 3 minus I. So by 3 minus I will multiply this, 3 plus I will multiply this. So let us write first, we don't multiply directly. 3 minus I into 1 plus I x. 3 minus I into 2I. That is finished here. 3 plus I will multiply here. 3 plus I into 2 minus 3I plus I into 3 plus I. 0 plus I dot 1. That will be as it is. This one down one, you know, 3 square plus 1 square. A plus IB into A minus IB. Now we will multiply this. 3 into 1 is 3. 3 into plus I is 3I. Minus I into 1 minus I. Minus I into plus I is minus I square. Minus. Here minus sign is there. Whenever you get minus sign, you must be very careful. So always put bracket. 3 into 2I, 6I, minus I into I, 2I, minus 2I square. 3 into 2, 6, 9I plus 2I minus 3I square plus 3I plus I square equals to 0 plus 0 dot I, 0 plus I1, sorry, I1. So here x is left, this x is there. Okay. So I am verifying that whether I have done everything correct or not. 3 square is 9, 9 plus 1, 10. Now 3 plus 2I, 3I plus minus I, 2I, this is plus 1. X minus 6I, let the minus be here for time being, minus 2I square is plus 2. 6I plus 2. 6 minus 7I plus 3. Minus 3I square is plus 3. Plus 3I minus 1 equals to 0 plus I dot 1. 3 plus 1, 4 into x, 4x. 2I into x, I 2x. Minus 6I minus 2. Remember this. Plus 6 plus 3, 9. Minus 7I plus 6 plus 3, 9. 9 minus 1, 8. We can write directly 8. Minus 7I plus 3 minus 4I equals to 0 plus I dot 1. Three plus there is some mistake now. Here y, here y, here y is left, y is left. Okay, there is some mistake. Okay, sorry for that. Plus 3y plus 3I minus 1. Okay, 4x plus I 2x. 3 plus 1 4 into x 4x I 2x. 6I minus 2. 6y minus 7y I 7y plus 3y plus 3I minus 1 divided by 10 equals to 0 plus I 1. Let me write again 4x plus I 2x minus 6I minus 2. 6y plus 3y is 9y. Yes, 9y. 9y. 6y plus 3y is 9y minus I7y. I7y plus 3I minus 1 equals 0 plus I dot 1. Now, let us write real part. 4x plus 9y minus 2 minus 1 minus 3. 4x plus 9y minus 3. This is real part. I. Now we will write the imaginary part together. Minus I7y plus I2x then minus 6I. Okay, 4x plus 9y minus 3. Let us write once more 2x I 7y minus 6I by 10 equals to 0 plus I dot 1. Here now we can write 4x plus 9y minus 3. Here I and x, sorry, I can be taken common. 2x minus 7y minus 6. 2x minus 7y minus 6. 6i, there is some mistake I think. 6i minus 6i plus 3i is minus 3i. Minus 3i minus 3. So 10 equals to 0 plus I dot 1. 2x minus 7y minus 3. Okay. Now we have got real and imaginary parts separately. Clearly, by 10 equals to 0. Real part. Imaginary part 2x minus 7y minus 3 by 10 equals to 1. Real part equals to real part, imaginary part equals to imaginary part. This one you have to now just one more calculation. 4x plus 9y minus 3 equals to 0. 10 into 0 is 0. Here 2x minus 7y minus 3 equals to 10. 4x plus 9y equals to 3. 2x minus 7y equals to 13. This is equation number 1. This is equation number 2. This equation number 1 and 2 you can solve by any process, any method of linear simultaneous equation. Just to check the calculation only. Now we will go to number 5. 7 number 5. 7 number 5. Yes. Now before I go to do this, 1 by I equals how much? We know that 1 by I is minus I. That I already explained. Why 1 by I is minus I? Because I and I will multiply denominator I into I square. I square is minus 1. up there is I. So I by minus 1 is minus I. So 1 by I is minus I. So 2 by I is minus 2I. 3 by I is minus 3I. So here I plus 2 by I, we can write minus 2I. I hope you understand. 1 by I is minus I, 2 by I is minus 2I. So this can be done directly like this. Okay, this one as usual, 1 plus I into 1 minus I, 1 minus I into 1 minus I equal to x plus I, y. This one I minus 2I plus minus minus 2I. So this one 1 square plus 1 square. This one 1 minus I whole square equals to x plus I, y. This is minus I minus 2I is minus I. Let it be like this for time being. Now this is 2, a minus b whole square, a square minus 2ab plus b square equals to x plus iy. Minus I for time being keep as it is. Always do the calculation is in an easy process. Don't make it complicated. Otherwise, there is chance of having some mistake. 1 square is 1, 2 into 1 into I is 2I, I square is minus 1 equals to x plus iy. Minus 1 plus 1 cancel. Minus I. Okay, let us write minus 2I by 2 equal to x plus iy. Here also 2 cancel. Minus I into minus I is minus I square equals to x plus I y. What we have got? Minus I square is how much? What is the value of minus I? I square is itself minus 1. I square is itself minus 1 and 1 more minus, so only 1 equals to x plus I y. So this one you can 1 plus 0 into I, x plus iy, a plus ib form. So x equals to 1, y is equal to 0. Finish. Imaginary part directly we can write. Number 8. Number 8 is important sum. So please take it seriously. Please have a note. This is an important sum. So what is given? Square root of a plus ib equals to x plus iy. It is given. So since root is there, so you will do squaring both sides in order to remove square root. Why we are doing squaring both sides? To remove square root. So square root cancel, a plus I b is left. A plus b whole square, a square plus 2ab plus b square. Simple. A plus ib x square plus I to xy minus y square. A plus ib. Here let us write real part together. Now real part and imaginary part is clear to us. So equating real and imaginary part, we get, I have written shortly, please you don't write shortly, you will write full. A equals to x square minus y square and b equals to 2x y. I hope you understand. Now to show that this equals to this. Now left hand side, square root of a minus ib, left hand side. We know the value of a and b. We know the value of a and b, just we'll put the value. A is x square minus y square. B is, I is there, I as it is, b. B is 2xy. Let us see now what can be done. X square minus 2ab. This one and this one same or not? It is same. I is there, I, 2, x into y, xy. Plus iy whole square. This one and this one same or not? Look here. I square is minus 1. There is minus sign. Y square is y square. So same. So whatever I have written here, this line and this line both are same. Just I have written this in term of a square minus 2ab plus b square. So that we can get a minus b whole square. Because in right hand side a minus b, minus sign is there. So that should be our aim. That should be our aim. Once again, let me tell you. This term and this term same. This term and this term same. Why? In order to get a square minus 2ab plus b square form, so that we can write a minus b whole square. So that we can get a minus b whole square. We are trying to get minus, because in right hand side minus is there. Our aim is to get that. But while doing a sum, you have to see right hand side also at the same time. What we are going to do. So a square minus 2a plus b square is a minus b whole square. What is a? X. What is b? Iy. A, b. Now square root cancel. X minus iy. X minus iy equals to right hand side. This is finished. Number 9. If the conjugate of 2a plus ib is a plus 4 minus I plus a to b, find the value of a and b. So conjugate means bar. So conjugate, this, just think that this is called C, not called C, conjugate. Conjugate of 2a plus ib is this. So I have written this. According to question, whatever given, just I have written here. Now, bar 2a plus ib, so remove bar minus ib. So we will do the calculation now. Very simple. Now here this is real part, real part. This is imaginary part, imaginary part. Equating. Directly you can do equating real and imaginary part. We get, what do we get? 2a equals to a plus 4, real part and real part equal. And minus and minus, both minus signs, so no problem. Directly we can write b equals to a plus 2b. If there is minus sign, here there is plus sign, then we will have to write as it is. But here minus minus cancel. 2a minus a equals to 4. b minus 2b equals to a. Minus b equals to a. A equals to 4. So minus b equals to 4. b equals to minus 4. I think it is correct. Number 9. A equals to 4, b equals to minus 4. So find the value of a and b. We have got a equals to 4 and b equals to minus 4. This is very simple. Number 10. Find the additive and multiplicative inverses of the complex numbers. Number 1, minus 4 plus I. So additive inverse, I have written again so that you can remember, you can call back. Additive inverse of z is minus z. So that both if we add, we have to get 0. Plus 1, minus 1, 0. Plus 5, minus 5, 0. So multiplicative inverse means what? Multiplicative inverse of z is z inverse. So that z and z inverse, if we multiply, you get 1. Like this, a plus ib into 1 by a plus ib equals to 1. This is z. This one is z inverse. So this one already explained. So just reminder here. So first of all, we have to write additive inverse. Additive inverse is directly 4. So what? If z, then minus z. This is z. This is z. Minus z. So minus 4 plus I. So what you will get? Plus 4 minus I. So finish. Additive inverse is finished. Just to put minus sign. Multiplicative inverse. 1 by minus 4 plus I. This is z. 1 by z. If z, multiplicative inverse of z is 1 by z. So z is minus 4 plus I. Multiplicative inverse 1 by. So minus this one. Same calculation. Minus 4 plus I into minus 4 minus I. We will have to do the calculation now. Because complex number is denominator. A square plus B square. Here B is 1. Minus 4 minus I. 16 plus 1. Minus 4 minus I. Minus 4 minus I. 17. Finish this one. This one you can write A plus IB form. Minus 4 by minus 4 by 17 I 1 by 17. Number 2. 2 plus I into 3 minus 2I. Now we will not do anything. We will make it A plus IB form. After that we will go to additive inverse and multiplicative inverse. First of all, we have to get this term in A plus IB form. Then only you can do any sum. Any question answer. 2 into 3 is 6 minus 4I plus 3I minus 2I square. 6 minus I plus 2. 8 minus I. Now additive inverse. Additive inverse, just we will put minus sign. This is z minus z. Minus sign. So minus 8 plus I. Finish this one. Now multiplicative inverse. What is z? 8 minus I. Multiplicative inverse 1 by 8 minus I. So this is multiplicative inverse. Just you can see the calculation. Having putting, just pause the video and you can see the calculation. I hope you have got my audio, my voice, as Bihu is going on just near to me. So I hope you don't get any disturb. If the sound is clear, you can understand. Number 10. Find the additive and multiplicative. Sorry, number 10 means number 1 and 2 already done. Number 3, so number 10 only there are 2 sums, I think. Yes, number 11 now. If Z1 and Z2 be any 2 complex numbers, can we write this and this? What? Real part of Z1 into Z2 equals to real part of Z1 into real part of Z2 minus imaginary part of Z1 into imaginary part of Z2. So for any 2 complex numbers, so taken let Z1 equals to A plus IB, Z2 equals to C plus IB. Because not given, so we have taken let. Now this is what we will find out first, Z1 into Z2. Z1 is A plus IB, C plus ID, Z2. So we will multiply. Simple multiplication. AC plus IAD plus IBC plus I square BD. AC plus IAD plus IBC I into I square minus BD. AC minus BD together because there is no I real part. IAD plus BC. Real part, imaginary part I have kept separately because A plus IB form. Now, number A will do. Left hand side, real part of Z1, Z2. This is left hand side. Real part of Z1. Real part of Z1 is A. Then real part of Z2 is C. Sorry. Real part of Z1. Not this one. Real part of Z1 into Z2. Z1 and Z1 into Z2 we have done already. This is the real part. This is the imaginary part. Real part of Z1 into Z2. This is the part AC minus BD. Then we will go to right hand side now. Real part of Z1. Real part of Z1 is, this is Z1. A plus IB. A is real part. So I have written this one. Real part of Z2. For Z2, real part is C. So I have written C. Then minus sign. Minus. Imaginary part of Z1. This is Z1. For Z1, imaginary part is B. Imaginary part of Z2. Z2. Imaginary part is D. Left hand side AC minus BD. Right hand side also AC minus BD. So this is proved. Number A is proved. Number B also you can do directly. What is given left hand side? Imaginary part Z1, Z2. Imaginary part, this is the result of Z1, Z2. This is real part, this is imaginary part. Here is an imaginary part of Z1, Z2. Z1 into Z, imaginary part of Z1 into Z2. AD plus BC. This is the imaginary part of this multiplication. Right hand side. Let us write first what is right hand side. Real part Z1, imaginary part Z2, imaginary part Z1, real part Z2. It is very easy sum. Just to see what is written, just to look what is written and follow the formation. Real part of Z1, A. Imaginary part of Z2, D. Imaginary part of Z2, Z2 is here. Imaginary part is D. Then plus. Imaginary part of Z1. For Z1, imaginary part is B. Real part of Z2. This is Z2. Real part is C. So C. AD plus BC. AD plus BC. Left hand side, right hand side equal. Very simple. This is done already. Number 12. Okay. If P plus IQ equals to alpha plus I by alpha minus I, then show that alpha Q equals to 1 plus P. Here you don't have to think anything. You just to do calculation and you will get. P plus IQ equals to alpha plus I by alpha minus I. What you will do? P plus IQ. This is general information. Generally we know what we know, that whenever we get I or complex number in denominator, then we have to remove complex number from denominator. So this is the process already we have done many times. Alpha minus I multiplying by alpha plus I. P plus IQ equals to alpha minus A plus IB, A minus IB, A square, B square. This is alpha plus I whole square. A plus b into a plus b whole square. P plus IQ alpha square plus 1. A plus b whole square. A square plus 2ab plus b square. P plus IQ alpha square plus I 2 alpha 2 into alpha into I to alpha plus minus 1. I square is minus 1. Alpha square plus 1. Or P plus IQ equals to what can be written? This real part let us write together. Alpha square minus 1 plus I to alpha by alpha square plus 1. Or we can write now separately imaginary and real part. Alpha square minus 1 by alpha square plus 1 plus I 2 alpha by alpha square plus 1. I hope you understand this one. This is the denominator for both real part and imaginary part. I have written separately. Now at least we have understood equating real and imaginary part. We get, what do we get? P equals to alpha square minus 1 by alpha square plus 1. What do we get? Q equals to 2 alpha by alpha square plus 1. We have got the value of P and Q. Now what we have to do? Show that alpha Q equals to 1 plus P. Let us go to left hand side. Left hand side. Alpha Q. Alpha, let it be as it is because we know the value of Q. What is Q? 2 alpha by alpha square plus 1. Just we have put the value of Q. Nothing done. So let us see what do we get. Alpha square plus 1. Alpha into 2 alpha square. 2 alpha square. We have to get 1 plus P. 1 plus P. What is P? Alpha square minus 1 by alpha square plus 1. Here 2 alpha square by alpha square plus 1. Now, what can be done here? We have to get P plus 1 plus P. So let us do right hand side. Let us do right hand side, no problem for us. This is left hand side. Let us do right hand side. Right hand side 1 plus P. Because we know the value of P. This is P. 1 plus P. Alpha square minus 1 by alpha square plus 1. So LCM. Here alpha square plus 1 plus alpha square minus 1. Plus 1 minus 1 cancel. 2 alpha square by alpha square plus 1. This is left hand side 2 alpha square by alpha square plus 1. This is right hand side 2 alpha square by alpha square plus 1. So left hand side equals to right hand side. This is finished. Number 2. Number 2. 12 number 2 is very important sum. This is important sum for exam. So please have a note for that. Now x plus iy equals to a plus ib whole square. Find the value of this. So find the value of x square plus y square. That means we will try to get the value of x and y separately by equating real and imaginary part. That is known to us. So whatever given, we let us write first. X plus iy equals to a plus ib whole square. This is given part. So x plus iy, this is a plus b whole square formula. A square plus 2ab plus b square. X plus iy, a square plus I 2ab minus b square. X plus iy, we will keep a real part together. Real part together so that we can equate plus I 2ab. Now equating real and imaginary part, we get x equals to a square minus b square. Real part, y equals to 2ab. We have got the value of x and y. We will find out the value of x square plus y square now. X square plus y square. X square plus y square. We need to find out the value of x square plus y square. We know the value of x and y. So we'll put the value. X square. X is a square minus b square. Square is there. X is a square minus b square. X square. Y is 2ab. 2ab whole square, because square is there. Now we will apply the formula. A minus b whole square formula. A square minus 2ab plus b square. This one plus 4a square b square. A to the power 4 minus 2a square b square plus b to the power 4 plus 4a square b square. A to the power 4 minus 2a square b square plus 2a square b square plus 2a square b square plus b to the power 4. This one we can write directly a square b square, a square plus b square whole square. X square plus y square is equal to a square plus b square whole square. Or this one, if you have not understood, then you can see this a square square plus 2ab plus b square. This one same. A square plus 2ab plus b square is a plus b whole square. So I hope you have understood. So this is the end of the exercise 2.2. Next video we will learn diagrammatic representation of complex number in a plane. That means graph of complex number. We will learn in next video graphical representation of complex numbers. So till then, have a good day, and we will discuss everything in next video for exercise 2.3. I hope. Exercise. Next video we will do the exercise 2.3. So till then, have a good day.